Today we'll start with first we'll understand. Suppose you are given any 2 degree any equation in two variable, right? And suppose you are asked whether this complete expression can be factorized or not, then how to find that, how to identify which equation will be factorized and which cannot be, like general equation in two variable. This is very important equation, and we'll be using it uh, very much in coordinate geometry and everywhere in math. So general equation in two variable, better 2 degree general equation, 2 degree general equation in two variable. So this equation is given as ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c equal to g. This is called 2 degree general equation in two variable. Variables are x and y, and you can see that all the terms have degree 2. See, x squared, y squared. No, sorry. I mean, degree is 2 because maximum power of x and y is 2. And here also you can see that power of x is 1, power of y is 1. If you add, you will get 2. Right? So this is general equation in two variable of degree. Now, suppose you are given this kind of equation, and we have to check that whether this can be factorized or not. Then what are the conditions? That we'll understand. So, condition for above equation to get resolved into two linear equation. क्या होगा वो derive करते हैं कि under what condition we'll say that yes, this can be resolved into two linear equation. How? See, first of all, we'll assume that this is a quadratic equation in x or in y, in any one of the variable. In any one variable, we'll assume that this is quadratic. Suppose we assume that this is the quadratic in x. So this can be written as 2hy, and there is x here and x here. So 2g. And this term containing y will be treated as constant. So you can see that this is your quadratic equation in x. Now we'll find the root like we do. X equal to minus b plus minus under root b square minus 4ac upon 2a, like that. So minus b, 2hy plus 2g plus minus under root b square. So square of this. So 2 will come out 4 and hy plus g whole square minus 4a and this c on 2a. 4, 4, 2, 2, 2 gone. X equal to minus hy plus g plus minus under root, open this, a plus b whole square, that is a square plus b square plus 2ab minus multiply this ab square minus 2afy or minus ac upon a. Now you can see that. So we have two different roots, one with plus sign and other with minus sign. But under this, we have variable y. So we can say that this can be separated into linear equation if this square root, whatever like we have inside the square root is perfect square, then only we can be able to remove a square, otherwise not, right? So for that, this has to be a perfect square, right? So this can be resolved into two linear factors only when whatever we have inside the square root should be perfect square. H square minus AB into y square. So this is y square, this is y square, and this y. So plus 2 GH minus AF y and plus G square minus AC. This can be resolved into two linear factors only when this is perfect square. Now we can see that this is quadratic in y, and if this quadratic expression is perfect square, it means that discriminant of this must be 0. So discriminant of this must be 0. So b square, that is 4 gh minus a whole square minus 4 a and c equal to 0. 4 gone. Open this. G square h square plus a square minus 2 a g h. Multiply here h square g square plus h square ac plus ab g square and minus a square bc. This is equal to 0. Now this and this gone. We have I think I missed something here. Oh, this is AF. So this should be AF. So A square F square or F. Yeah. So now we can see that we have A square F square and minus 2A GHF plus H square AC plus AB G square minus A square BC equal to 0. And we know that, see, A is the coefficient of x square. So A is not going to be 0 as A can't be equal to 0. A1A can be cancelled out. And now take minus common. So we have ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. And also we know that because these things, you can see that this quadratic equation expression is inside the square. So in a square, like no, square does not allow any negative value. So the leading coefficient of this quadratic has to be positive. If it is negative, graph will be downward and it will come down and it will become negative, right? So it has to be positive. So we have these two equations. X square minus AB has to be positive. So these two, and we have ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. So now if I summarize, I can say that if AX square plus 2HXY plus BY square plus 2GX plus 2FY plus 3 equal to 0, if this can be resolved into two linear factors,
Sir, I have a doubt.
then these two must exist. Or if these two exist, then only we can say that this can be factorized into two linear factors. So इसको ये factorize इसका दो linear factor होगा, उसके लिए ये दोनों condition satisfy होना चाहिए. You have to remember this. You do not have to put a lot of effort in understanding the derivation, but you have to remember this end result. This is very important. Huh? Tell me, I have seen.
Sir, in that line a square f square, how is a getting cancelled?
Right? You can take a, like each term has a, na? And here right side we have 0. So if you divide by a, 0 by a is 0, na? Simple.
Okay, okay.
So can you go up? I have to see the top button. No, not there, sir. A little below. After the statement. Yeah, here, sir.
Sir, could you please scroll down?
Noted?
Yes, sir.
Done, sir.
Now, so you have to write this formula a couple of times so that like you could remember this. Now, if I take one question, find the linear factors of 2x squared minus y squared minus x plus xy plus 2y minus 1. See, question directly asks you to find the linear factor. It means that it must be having. That's why you have to simply find the linear factors of this, right? But I also want to see how to apply that condition. So let's first apply that condition. So that we can understand how do we suppose in case sometime you're not supposed to find the linear factors. You just have to identify whether this will have or not. So how do you apply that condition, right? So first see, write the general equation. Write the general equation. What is that? Ax squared plus 2h xy plus by squared plus 2gx plus 2fy plus c equal to 0. Suppose. Now compare these two equations. Compare. On comparing. You can compare. See, what is the coefficient of x squared? A. And what is the coefficient of x squared here? 2. So A must be 2. And 2h is how much? 2h is the coefficient of x into y. And what is this term in this equation? What is the coefficient of x into y? That is 1.
Fine.
So 2h is 1. So h is half. And b is, see, by square here minus y square. So what is the coefficient of y square here? Minus 1. So with sign we'll take b is minus 1. And g is how much? 2g is minus 1. So g is minus 2. 2f is 2. Right? So f is 1 and c is minus 1. You just have to compare these two equations. And now, first thing you have to check is h square minus ab. It has to be positive. So h is how much? Half. So half whole square minus a is 2 and b is minus 1. See, 1 by 4 plus 2. Yes, this is positive. Now you have to check abc plus 2fgh minus af square minus bg square minus ch square. This must be 0. So a is 2, b is minus 1, c is minus 1 plus 2. F is 1, G is minus half, and H is plus half. Minus A is 2, F is square. So 1 minus B. Minus plus B is minus 1. And BG. G means G is minus half. That is 1 by 4. And minus CH square. C is minus 1, minus 1 plus, and H square. That is 1 by 4. Now you can see. We'll check the value. This is plus 2. This and this gone. So this is minus half. This is minus 2 and 1 by 4 plus 1 by 4. That is plus half. See. Yes. So it meets both the condition, right? It means that it will have two different linear factors. Now, question arises, how to find that linear factor? Now we'll find it. This is very easy. So now we have to find its linear factor. So what we will do is, we'll consider this to be as either quadratic in x or quadratic in y. So we'll modify this equation like this. Suppose if I assume that this is the quadratic in x, so we'll write this like that. So separate the value of separate the term x. So this is y minus 1 into x. You can do the same in y as well, no problem with that. Minus y square minus 2y plus 1 equal to 0. Now do one thing. See, find x minus b plus minus under root b square minus 4a, and this is again y minus 1 with minus sign upon 2a, that is 4. So you can see that y minus 1 plus minus, this is your 9 times y minus 1 ka whole square upon 4. So this is minus y minus 1 plus minus 3 into y minus 1 upon 4. So x can be either, if you take plus sign, minus 1 plus 3 plus 2 and by 4. So half y minus 1 factor will come from here. So 2x minus y plus 1 equal to 0. And if you take minus sign, then it is simply y minus 1. Minus 1, minus 3, minus 4, 4 cancel. So x plus y minus 1 equal to 0. So these two are the factors of this equation. Understand? Note it down.
Three pair of straight lines जैसे.
हाँ, काइंड ऑफ वैसा ही है. उसका एक अलग ही, हाँ, डेल्टा इक्वल टू 0 उसमें भी होता था.
हाँ sir.
उसको कोऑर्डिनेट ज्योमेट्री में और भी पढ़ेंगे इसको.
Done, sir.
That all, everyone has done it? Written? Okay. Now let's take a few questions. X comma y belongs to real number. Satisfy the equation x square plus y square minus 4x minus 2y plus 5 equal to 0. Then find the value of the expression root x minus root y whole square plus 4 times under root xy upon x plus root xy. Try. समझ में आया कैसे करोगे? समझ में नहीं आया होगा? नहीं ना ब्रो?
तो सर इतना मालूम है ये एक सर्कल का इक्वेशन है।
वाह ओके, देखो सी,
So
हाँ
I have a question. So in the previous question, for the quadratic equation, how did you solve it, sir? Can you show that again?
ये देखो इसको. Okay, let me solve this question. Otherwise, I'll again have to write it. Then I'll go back to that
No,
question. First, let me solve this question. Then I'll erase it. Right? See, just to make the perfect square. See, x squared minus 4x. X squared minus 4x. Take 4 from here, and then y squared minus 2y and plus 1. See, from here we can see that this can be written like this. Now you can see that this is also a perfect square. This is also this is also a square of something, and this is also a square of something. So square of anything can never be negative, right? So a square of anything can be either 0 or more than 0. So this can be greater than or equal to 0. This can also be greater than or equal to 0. Sum of these two positive term will be 0. It means that these two have to be individually 0. Otherwise, this is all square of something. So this is always positive or 0, right? And sum of two positive things can't be 0. But here we have 0. In this case, both has to be individually 0. दोनों को 0 होना पड़ेगा. So we have x equal to 2 and y equal to 1. Put this value in this expression and find the value. Understood?
सर आगे
आगे चले आगे.
करेक्ट है ना √2 + 1/2।
नहीं, √2 + 1 upon √. आंसर में ये लिखा हुआ है. सॉल्व करूं क्या?
हाँ सर करेक्ट है √2 है।
so is it? Yeah, same.
सबका हो गया? Everyone written? Okay, now let me go back to the previous question.
Sir, I'm getting √2 + 1.
हाँ, √2 + 1 by √. You are not getting √2 in denominator?
No, sir.
Check it now. You have to put the value here as well, na? In denominator as well. And see now. Let me see. Put x equal to 2. √2 minus 1 plus 4 √2 whole square upon 2 plus √2. So this is 2 plus 1, 3, and then minus 2 √2 and plus 2 √2. And then 2 plus √2. So this is 1 plus 2. Okay, 1 plus. Solve करके देखो ना. And root 2 minus 1.
rationalize करने से 6 minus 3 root 2 plus 4 root 2 plus 4 whole divided by 2.
Yeah. 6 minus 3 root 2 yeah, plus 2 root 2 minus 2 4 by 2.
सर ये बहुत कॉम्प्लिकेटेड
So
मेथड है, इसको
B plus
डायरेक्टली
4 root 2.
न्यूमरेटर
Huh?
में आप रूट एक्स प्लस रूट वाई द होल स्क्वायर लिख सकते
So it's not 2 root 2, so it's plus 4 root 2.
हाँ कहाँ पे साइन है where?
Left side equation. You've written minus 3 root 2 plus 2 root 2. It should be plus 4 root 2.
Why so?
Isn't it? Yeah.
Right. So 2 plus root 2 by 2. So just take root 2 common, root 2 plus 1, and that root 2 will cancel 2 by root 2. Can I see? हटाओ. Hmm. Tell me, Saina. Where?
So under the roots, how did you like y minus 1 squared?
Simple, na? See, nothing. Minus 2 into 2 minus 8 into minus 1 plus 8. Same, we have y minus 1 whole square, y minus 1 whole square. So this is 1 time, this is 8 times. So 9 times y minus 1 whole square. Na? So 3 y minus 1 square into 1.
Oh.
One more question, then we'll go to next topic. If PQ belongs to 1, 2, 3, 4, 5, then find the number of equations of form p square x square plus q square x plus 1 equal to 0 having real roots. So
So 2 solutions?
$16.
Huh?
Four minutes. Okay, let me help you. Let me solve. See, PQ belongs to this. So PQ can have any value out of these five values. It can be like P or Q, any variable can take any value, either 1, 2, 3, 4, or 5, any value. So we have to find the number of equations of this form so that this equation will have a real root. So for this equation to have real root, we know that discriminant has to be greater than or equal to 0. That real root may be different or may be equal. So this is B is,
So I'm getting 8 or 10. I did the same method as you did it, sir. Discriminant is
sorry. So B square, so B square minus 4AC, that is this, greater than or equal to 0. So from here, we can say that
yeah, sir. You'll get 2p is less than or equal to q square.
like this or this is always positive, right? We know that. So we have to see this term. It means that Q square has to be greater than 2P square. Now this condition must satisfy. Now we have to pick P and Q. See. P, if you take P, 1. Suppose if you take P1, Q can take value. So P, if you take P, so this left part would be how much? 2 into 1 square root 2. So Q can be 2, 3, 4, 5. Q can't be 1 because 1 square cannot be greater than 2. But if we take Q2, then 2 square. So 4. 4 is greater than or equal to 2. 9 is greater than or equal to 2. So all these values of Q can satisfy this, right? But if you take P as 2, so 2 into 2 square, that is 2 into 4, 8. So in this case, Q square has to be greater than or equal to 8. So you can't take Q equal to 1. Otherwise, 1 is less than 8. 2 you cannot take. 3, 4, 5 you can take. Because 3 square is greater than or equal to 8. And if you take P as 3, Q you can take.
Sir,
P is 3.
sir. A square minus B square, तो Q square plus 2P होगा ना? 2P square तो नहीं होगा.
तो ये है ना, बट दिस इज ऑलवेज पॉजिटिव, ये तो हमेशा पॉजिटिव होगा ना, इसी क्या करना है.
हाँ तो A square minus B square A plus B A minus B तो 4P square का रूट तो 2P होगा.
Yeah, sir. It's not 2p square. It's
2P
just
square नहीं है 2P.
Oh, yeah. Okay, my bad. It's my bad. Okay, fine. Okay, so Q square is greater than 2P. Okay. Suppose if you take P equal to 1, so 2, then also it is right. If you take P as 2, so 4, so 4 means, now you can take 2 as well, because 2 is square is 4. 4 can be greater than or equal to 4. So 4 is equal to 4. If you take P equal to 3, so Q square has to be greater than or equal to 6. So now you can see, if you take Q equal to 1, 1 square is not greater than or equal to 6. 2 square is not
Sir?
greater than or equal to 6.
Why don't we take q square plus 2p is greater than equal to 0?
And because see, P and Q can take value, these are positive
Oh, they're
values.
not no negative values. Okay.
So if we take P as 4, so Q square will be greater than or equal to 8. So now you cannot take 1, cannot take 2, but you can take 3, 4, 5. Now if you take P equal to 5, in this case, Q square is greater than or equal to 10. So you cannot take 3, you can take 4 and 5 only. So for one value of P, we can take 4 different value of Q. So we can form 4 different equations, right? One value of P, four different value of Q. So 4 equations from here, 4 equations from here, 3 equations from here, 3 equations from here, 2 equations from here. 8 and 14, 16, right? Understood, everyone?
So I did the same thing, but I didn't do the counting correctly for Q and P.
Okay, no problem. No problem, madam. Next time, we will not make any mistake. हमने लिख लिया
एक मिनट
आर्यन अर्चित समझ में आ रहा है तुम लोग को
हाँ यस सर
चले आगे बिठाओ लिख लिया नोटेड
एक मिनट ओके
okay now next point is transformation of equation transformation of equation. Means suppose you have this quadratic equation ax square plus bx plus c equal to 0. And this quadratic equation has two roots, alpha and beta. Now, if I say that, if find the equation, find find uh, the equation whose roots are minus alpha and minus beta. See, there are two ways to do this. So one way you can find, like we know that if roots are given, then what is the equation of quadratic? What is the quadratic? What is the equation of quadratic equation? That is x square minus sum of roots into x plus product of roots equal to 0. This we know. Now we have roots given, that is minus alpha minus beta. So minus alpha and plus minus beta into x plus product of the roots. So from here we can take minus out. So this minus minus will become plus alpha plus beta into x plus alpha into beta equal to 0. We know that this equation has two roots, alpha and beta. If you find some of the roots, you will get minus b by a and alpha into beta as c by a. So just we use these data. So put here x square minus b by a into x plus c by a. Cross multiply by a. So now ax square minus bx plus c equal to 0. So now, if alpha beta are the roots, we have this equation. Then if alpha minus beta are the roots, we have this equation. And the other method we can simply use is, see, we know that method 1. This is the method 1. And this is the method 2. Ax square plus bx plus c equal to 0, we have two roots, alpha and beta, right? And now we have to find the equation whose roots are minus alpha minus beta, right? So we can see, x equal to alpha is 0. And we have to find equation whose roots are this. So y equal to minus alpha and y equal to minus beta. You can take any value. Now alpha equal to minus y can be written. We know that this alpha is root of this equation. Na? This alpha is root of this equation, and root always satisfy the equation. So satisfy a alpha square b alpha plus c equal to 0 and put alpha equal to minus y. So a minus y whole square plus b minus y plus c equal to 0. So ay square minus by plus c equal to 0. Y is just a variable. You can remove y by x. You can replace y by x. So just replace y by x. You can see you have got this thing, right? You have got this thing. So if roots are given like alpha and beta, and you have to find the new equation whose roots are minus alpha minus beta, just replace x by minus x. Just replace. So point that we should note is replace x by minus x in original equation. Note it down. But don't try to remember, try to understand.
Done, sir.
Everyone noted? Okay, just raise your hand. इस बार अब्रो पीछे हो गया सबसे लास्ट में।
हो गया सर, हो गया।
ठीक, अब सेकेंड पॉइंट से मतलब I'll take same like we'll continue with this thing only. Second point is like see these two are fixed thing. Like we have this ax square plus bx plus c equal to 0, and we have two roots alpha and beta. Now second point is if roots are reciprocal, means 1 by alpha and 1 by beta, then find the new equation. So again you will do the same thing in the same manner. How would you find? I am telling you like both the methods for now. Method 1, we know that x square minus sum of the roots. So we have roots like this into x plus product of the roots. So this is the general method. I hope everybody remember this formula. Now x square minus, take LCM, alpha plus beta upon alpha into beta into x plus 1 by alpha into beta equal to 0. Just cross multiply, just multiply by alpha into beta. So this will become like this. Now you have alpha plus beta from here, you can use. Alpha into beta is c by a. Just put here c by a into x square minus minus plus b by a into x plus 1 equal to 0. So cx square plus bx plus a equal to 0. This is the required equation. Now, so this is the authentic way, right? Now, if I do, we can see that like this is the reciprocal of these roots. Na? So in this equation, we'll just replace, if we replace x by 1 by x, do this. So if you replace x by 1 by x, because the roots are reciprocal, so we'll get the same equation that we got now. You can see a plus bx plus cx square equal to 0. See these two equations. So you can remember this short trick. This is method 2. Because this is the root. Na? So just imagine any variable y equal to 1 by alpha. Alpha, we know that alpha is the root of this equation. So alpha will satisfy this. So a alpha square plus b alpha plus c equal to 0. And alpha is 1 by y. So a 1 by y whole square plus b 1 by y plus c equal to 0. And then just replace y by x because y is simply a variable. There is nothing to worry about changing the variable.
So can you scroll a little bit to the bottom? So from here, how do we get the equation? How do we get C?
What c?
Like, sorry, CX squared.
See na, just take LCM na. A by y square, b by y plus c. Take LCM. This is a plus by plus c by squared na. Cross multiply it will be multiplied to 0 and gone. So cy square plus by plus a equal to 0. Just replace y by x. This is simple a variable. So cx square plus bx plus a equal to 0. Hmm?
So how did you get A in the end?
How did I get?
A, CY square plus BY plus A.
Where did I write a? This is y.
No, sir, CY square plus BY plus A equals 0.
Array from here na, this a na.
Oh,
cy
okay.
square plus by
Okay.
plus a.
Oh, okay, the same equation.
Hmm. Noted? Now, third point, like this is given ax square plus bx plus c equal to 0 has two roots, alpha and beta. Suppose if roots are alpha square and beta square, then you have to find the equation. Now, I'm not using the method one. I am simply doing the trick one. See, this is the root. That, with the help of these roots, we have to find the equation. So alpha equal to root y, and we know that alpha is the root of this equation. So alpha will definitely satisfy this equation. And now for this alpha, we'll put this. So a root y whole square plus b root y plus c equal to 0. Now you can see that y is simply a variable. So now here only I am replacing y by x. So one thing you can notice. So in this equation, if roots are alpha square, then we are replacing x by root x, right? Replacing x by root x. Now solve it. Ax plus b root x plus c equal to 0. You cannot leave it here because x has a square root. This is not polynomial as per the rule of polynomial. So b root x with minus sign can be written as ax plus c. Now square both these sides. Now square both these sides. This is b square x equal to a square x square plus c square plus 2acx. This is your quadratic equation, whose roots are alpha square beta square. समझा?
Yes.
Now you guys solve. Shall I erase? Everyone done, right? In the same question, I'll ask you guys to form the quadratic equation whose roots are alpha q and beta q. Same scenario. Form. I am writing the answer as well. Don't worry. You can match it. That will be aq x square plus x b cube minus 3abc. This is the answer, right? किसी को हुआ या किसी को नहीं हुआ? सब अपना अपना वीडियो ऑफ करके बैठेंगे। वाह,
सर हो गया।
क्या बच्चे! हो गया, आ गया, अबरू का आ गया। आयुषी,
नहीं सर।
आर्यन, शाइना, शानिया, शाइना, अर्चित,
Not yet, sir.
No.
देखो, I told you ना, see, wait. This equation ax square plus bx plus c equal to 0 has roots alpha and beta. So use any root, alpha. So alpha is the root, so alpha will satisfy this.
So I
So
got
here,
it.
now you have to find the equation whose roots are alpha cube. Suppose, let's say alpha cube. Let's assign any variable t. Now find alpha, that is t raised to 1 by 3. Because we'll find alpha so that we can put in this equation. Na? So in this equation, put alpha equal to t raised to 1 by 3. So t raised to 2 by 3 plus b, t raised to 1 by 3 and plus c equal to 0. Now what we'll do, we'll simply take c to this side and then take q. We'll take q. Now this is a plus b whole cube. So this is a cube plus 3 a square b plus 3 a b square plus b cube equal to. Simple. Now you can see that a cube na. Okay. Now this 3 will go, but cancel. So 8a square plus 3 a square and b. Now t raised to 2 by 3 and plus into t raised to 1 by 3. T raised to 2 by 3 into t raised to 1 by 3. If base are same, power will add up. So this will become simply t. 3a b square. Here again we'll have. Oh wait. No. My bad. This is t raised to 4 by 3 na. So t raised to 4 by 3 and this is t raised to 1 by 3. So this is 5 by 3. So t raised to 5 by 3. Or you can do one thing. Let it be 4 by 3 into t raised to 1 by 3. Like this only. 3a b square t raised to 2 by 3. And here t raised to 2 by 3. And here b t, that is equal to minus c cube. And one moment. Can't you replace that?
सर मैं तो फर्स्ट मेथड से।
नहीं, वो तो ठीक है, वो तो सिंपल है। मुझे इससे करना है।
सर फर्स्ट लाइन में a क्यूब t स्क्वायर नहीं होगा? फर्स्ट लाइन में a क्यूब t स्क्वायर।
किधर?
सर लास्ट में जो लिखा उसके फर्स्ट वर्ड पे a क्यूब t स्क्वायर।
हाँ ठीक है, कोई दिक्कत नहीं। बी क्यू टी, यहाँ पे कहाँ मिस्टेक हुआ? 3a स्क्वायर b, सो t रेज टू 5 by 3. ओके, यहाँ से ये आ जाएगा t रेज टू 5 by 3 एंड देन t रेज टू 4 by 3 कॉमन लेंगे तो उसे क्या आएगा अपने को? अल्फा। इससे कुछ आखिर में है, कटेगा क्यों नहीं? अच्छा ओके, ना क्या ओके? do one thing. This is a cube t square plus this is 3a square b t raised to 5 by 3 plus 3 AB square T raised to 4 by 3 plus BQ T equal to minus CQ. Now you can, from here you can see that we had this kind of relation. AT raised to 2 by 3 plus BT raised to 1 by 3, that is minus C. We have to use this relation here. So put here A cube T square. Take common from these two terms. 3AB will come common, but we have to take T as well common, so that we'll have A from here and then T raised to 2 by 3 and plus B from here and then T raised to 1 by 3 plus B cube T equal to minus C cube. Now see, we have this kind of relation. AT to the power 2 by 3 plus BT 1 by 3, that is minus C. Put here. We got the answer. That is A cube T square. This is minus C. So minus 3ABC T plus B cube T plus C cube equal to 0. Plus A cube, replace T by X cube plus B cube minus 3ABC into X plus C cube equal to 0. We had the same relation here. See, right? That is how we can do. Now you have to practice this because now I'm going to give you questions that will be handled by this method. That will be more beneficial, and also will get to learn new things. Method 1 was old one, note kar. Done, everyone?
sir.
China. Okay.
Almost.
Ayushi, Aryan. Aryan.
Done, sir.
चलो so that is how we can form the equation. Let me give you one question. Do not use method number one, like some of the roots, product of the roots. Do not use that. Do like how I taught you. Solve this. But yes, sometime the way I have I am suggesting you to do that may be little tough. So in that case, you can simply use some of the roots and product of the roots. No worries. Why taking so much time? See,
So, can you give us 2 more minutes?
Sir, x cube minus 9x square plus 21x plus 3 is equals to 0.
this is the answer. कितना तो अर्जुन बोल रहा था कितना आ रहा
सर मेरा क्यूबिक आ रहा है.
क्योंकि कैसे आएगा तुम खुद समझो ना कि अल्फा बीटा आर रूट्स ऑफ दिस
सर मैंने गलती से वो मतलब स्क्वायर की जगह क्यूब ले लिया उसकी वजह से क्यूबिक किया आ गया.
मैं मेथड 1 से कर दूंगा पहले मेथड 1 से
नहीं
करूंगा
मेथड
पहले
2 से ही हो गया था ये, बट
हाँ
मैंने गलती से
मेथड
क्यूब ले
मैं
लिया.
दोनों से करूंगा मैं तो see we have to find the equation whose roots are this and this so what is the
Yes.
equation then
So I
x
got
square minus हाँ sum of the roots one root and plus second root into x plus product of the roots equal to 0 x square minus 2 take 2 common 2 alpha plus beta And we have alpha plus beta from, we'll take alpha plus beta from here. That is minus b by a. So 3 by 2 and plus 6 here. And here multiply this. 4 alpha beta plus 6 alpha beta plus 6 alpha beta plus 9 equal to 0. So alpha square minus 9x plus alpha into beta how much? 3 by 2. So 4, 3 by 2 plus 12, 3 by 2 plus 9 equal to 0. 6 और कितना हुआ? ये एक्स्ट्रा आ गया ना? Sorry, गलत लिखा था. Like this. So this is 4 alpha into beta plus 6 alpha plus beta. That is 3 by 2 and plus 9 equal to 0. So this is x squared minus 9x plus 6 and then 18, 24 equal to 0. This was the first method. For second method, we have roots 2 alpha plus 3. Give it to any variable. Assign any variable to it. Alpha is t minus 3 by 2. And we know that alpha is root of this, right? So satisfy this.
Sir,
So 2 alpha square, yes, tell me.
sir, वो 2 alpha into 2 beta 4 alpha square. नहीं, correct, sorry.
Now, for this alpha, we put this thing. So 2 into 3 minus t by 2 whole square minus 3, t minus 3 by 2 plus 3 equal to 0. Just simplify this. 2 t square minus 60 plus 9 upon 4 minus 3 by 2 t minus 3 plus 3 equal to 0. Now, 2 cancel. Take LCM minus 3t plus 9 plus 6 equal to 0. T square minus 9t plus 24 equal to 0. Just replace the variable. Correct? Everyone done? This is very easy question. Correct, guys?
हो गया sir.
हाँ, मतलब सबका हो गया ना? किसी को अटका तो नहीं ना?
No, sir.
So do we do the question you sent?
Giving you, wait. Just copying, and then I'll be pasting. See, solve it. I guess you guys will be
सर
facing
आ
a
गया
difficulty in solving this question. अच्छा,
सर
आ गया?
आ रहा है
Sir, 1 minute. Sir, 1 minute.
Okay, okay.
सर मैं आपको एक पिक्चर भेज रहा हूँ आप बता सकते हैं आप ये करेक्ट है कि
भेजो।
सर इसके आगे मैं सॉल्व कर सकता हूँ पर मुझे जानना है कि यहाँ तक करेक्ट है कि नहीं
नहीं, ऐसे सॉल्व नहीं करेंगे, तुम लोग से नहीं होगा, मैं मुझे पता है, इसलिए बोल रहा था ना। सी, let me help you. See, we are not going to upload it, upload it lot of work. So we are not going to calculate much. We just use some concept that I just uh, I just before a couple of questions I taught you. In that way, we'll think. See, we are given this equation. So ax square. Understand carefully. This equation has two roots, alpha and beta. Now we have to find the roots of this equation. Now, what we'll do, our approach should be, so we have to find the roots of this equation, right? And we are given this thing. So what we'll do, we'll try to convert this equation in this form. We'll try to convert this equation in this form. So for that, we need to have a here, b here, and c here. It means that take a cube common. If you take a cube common, it will be like this, ab square, a cube plus 1. But we do not need 1, we need c. So just multiply by c. So just multiply by c. Right? We got b square c square upon a cube. X square minus a b square upon a cube into c into x plus c equal to 0. We need a into x square. So take a out. So take a out. So to balance it, we will multiply and divide by a. So we have this. And then minus we need b here, so take b out. So this is ab upon, so no, ab upon a squared na, a cube na, so a cancel, so this is okay. Now you can see here 1a cancel, 1b will be out, so this is b upon a square into c x plus c equal to 0. Now see, we need to form a x square. So for this, bcx upon a square. This is your complete x square, right? A x square minus b, c x upon a square c. If this is your capital X, this is your capital X, and plus c equal to 0. And if we have this kind of equation, ax square minus bx plus c, then value of x will be alpha and beta. So we have similar pattern. So a x square minus b x plus c. So this will have two values, alpha and beta. समझा? ये बात समझा? Did you understand this? So bcx upon a square equal to either alpha or bcx upon a square equal to beta. So b by a out, c by a out, x equal to 1. So now b by a you can take, see, right, sum of the roots, that is minus b by a, product of the roots, that is c by a. So for b by a, write alpha plus beta, and c by a, write alpha into beta. Alpha
Sir,
alpha cancel.
minus alpha into beta.
तो
And
माइनस
alpha
माइनस
plus
कैंसिल है बच्चा, यहाँ भी माइनस है, कैंसिल हो जाएगा ना, माइनस यहाँ भी तो है ना, ये माइनस कैंसिल होगा ना, b by a alpha plus beta, c by a alpha into x equal to beta, beta beta cancel. So x is 1 upon alpha into alpha plus beta. So this is first root, this is second root. Well, think a bit and then let me know whether you understood or not. There is no hurry. We are in learning phase right now.
So can you explain the right side part again from b square c square x square by a cube from the beginning?
See, we have to transform this equation into this form. So we have transformed this. Now, assume this is your capital X or this is your Y. So this
how
can
did
be
you
written.
how did you transform it, sir?
Sure. We have C here. So I just tried to make C here. So, but we have A cube here. So just now divided by A cube. So this is 1 and then multiplied by C. So this will become C. See? And now we have A into something. So I just took A out and whatever we have, that I put in bracket. A into something, minus B into something. So B into something, and I noticed that this something and this something is same. So I'll name it as some other variable. So AT squared minus BT plus C. AT squared minus BT plus C. It has two roots, alpha and beta. So T will be alpha and T will be beta. And T we have assumed this thing. So this is actually alpha and this is actually beta. And B by A we can replace in terms of alpha beta. C by A we can replace in terms of alpha and beta. Like that.
Okay, got it.
Got it, na?
Yes.
किसी को नहीं समझा तो वापस से पूछो.
Sir, could you explain the sum again, please?
क्या बोल रहे हो आर्यन?
So right part एक बार वापस समझा सकते हो?
देखो मेरी बात सुनो, तुम्हारे पास क्या है, ये इक्वेशन दिया हुआ है अपने को इक्वेशन दिया है कैसा, ए एक्स स्क्वायर माइनस बी एक्स प्लस सी इक्वल टू 0, जिसका रूट अल्फा एंड बीटा है. अपने को नया इक्वेशन दिया है, बोल रहा है कि इस इक्वेशन का रूट क्या होगा. तो हम क्या करेंगे, हम इस इक्वेशन को इस वाले इक्वेशन में कन्वर्ट करने की कोशिश करेंगे, ट्रांसफॉर्म करने की कोशिश करेंगे. तो इस इक्वेशन में तो सी है ना बेटा, तो यहाँ भी सी बनाएंगे. सी कैसे बनाएंगे, तो ए क्यूब हटा देंगे डिवाइड करके और फिर सी से मल्टीप्लाई कर देंगे. अब यहाँ पे a इंटू समथिंग स्क्वायर है, तो यहाँ पे ए अलग कर लिया हमने और बैलेंस करने के लिए मल्टीप्लाई नीचे भी कर दिया। अब ये बी सी ए स्क्वायर एक्स का होल स्क्वायर बन गया। सिमिलरली वहां बी अलग कर लिया और जो बचा यहाँ रह गया। हमने नोटिस किया कि ये टर्म और ये टर्म सेम है, सो इट इज लाइक ए टी स्क्वायर माइनस बी टी प्लस सी। तो वही तो है, ए टी एक वेरिएबल है, तो ए टी स्क्वायर माइनस बी टी प्लस सी, जिसका दो रूट अल्फा एंड बीटा। तो बेसिकली इसका वैल्यू ही होना चाहिए इसमें अल्फा, इसका वैल्यू ही होना चाहिए बीटा। अब बी बाई ए और सी बाई ए अलग अलग कर दिया हमने, अल्फा बीटा के टर्म उसको एक्सप्रेस कर दिया, कहानी खत्म।
Yes, sir. Thank you.
नोट करो। सबका हो गया?
यस सर।
Yes, sir.
ये लो, ये करके दिखाओ।
सर मेरी अल्फा की वैल्यू निकल गई बट उसके बाद सॉल्व नहीं हो रहा।
बताता हूँ, वेट। इनको देते हैं 2 मिनट और बस।
सर आंसर 1 है वैसे।
क्या?
आंसर 1 है।
एक सेकंड देख लेते हैं। टू। देखो क्या होगा, कह रहे कि अल्फा एंड बीटा आर द रूट्स ऑफ दिस इक्वेशन, राइट? अगेन वी विल ट्राई टू कन्वर्ट, we have to find roots of this equation. So again we'll try to convert this equation into this form, ax square plus bx plus. So see, a 2x plus 1 whole square minus b 2x plus 1 3 minus x plus c 3 minus x whole square equal to g. We need to form ax square. So just divide both side by 3 minus x whole square. So this will become 2x plus 1 3 minus x whole square minus b. 1 3 minus x 3 minus x will cancel and we will be left with this. Let's see. Now you can see this is a x square minus b. So we cannot take minus, right? So just do one thing. We have plus here. So we have to make it plus. So do one thing. So to make it plus, we have to adjust minus. So just reverse this. And if we have this kind of relation,
So
so
what did you? Why does it have to be plus? I didn't understand. Why is it
see,
minus?
in this equation, ax square plus bx we are given a plus
Oh,
here.
okay.
That's why. So plus. So we adjusted the negative sign. So we need to have similar terms here. So we also reverse this thing. And because we have a square here, so it is not going to impact the equation. So we can simply write. So this is your. So now this is your x. So this is alpha and this is beta. Like in this equation, ax square plus bx plus c, x is alpha and beta. So we have similar pattern. So this complete thing is alpha and beta. So if I solve it, 2x plus 1 upon x minus 3 equal to alpha. Similarly, or 2x plus 1, x minus 3 equal to beta. If we solve, we'll get x. And that x will be the root of this equation. So 2x plus 1 equal to alpha x minus 3 alpha. Alpha को मान लो ये इधर आएगा और ये इधर जाएगा. So 1 plus 3 alpha, that is alpha minus 2 into x. So x is 1 plus 3 alpha upon alpha minus 2. Similarly, यहाँ से क्या आएगा? 1 plus 3 beta upon beta minus 2. ये हो गया. Alpha minus 2, beta minus 2. समझ में आया? Like this.
Sir, could you
Understand
please
everyone?
scroll down?
Yes, ma'am. Scroll down and scroll up.
Sir, down.
हो गया ना?
Yes, yes.
आयुषी जी समझ में आया?
Yes, sir.
आर्यन बाबू आपको? अर्जित बाबू आपको?
Yes, sir.
चाइना एंड अब्रो तो दे आर इंटरेक्टिंग अ लॉट, बट तुम लोग थोड़ा कम इंटरेक्ट करते हो. आयुषी भी ठीक ठाक कर लेती है थोड़ा बहुत. अर्चित और आर्यन बहुत कम ही बोलते हो. थोड़ा बोलो. ऐसे ही बोलते रहो ना, जोक वगैरह सुनाते रहो, अच्छा लगता है. पॉजिटिव वाइब मेंटेन करके रखना है ना क्लास. पहली बात तो तुम लोग क्या जोक सुनाई है, वीडियो ही ऑफ रखते हो. तुम लोग तो पहला ही जो रूल होता है उसी को ब्रेक कर दिया. सब वीडियो ऑफ रखते हो, ये अच्छी बात नहीं है. वीडियो ऑफ में क्या कारण है? ऐसे रिलैक्स हो जाते हो क्या? लेट जाते हो क्या? नहीं ना. अगर लेट भी जाते हो तो क्या ही फर्क पड़ता है, मैं अलाउ करता हूँ लेट जाए. ये तो शक्ल दिखाते रहो ना, अच्छा लगता है. लगता है हाँ कि मतलब आई एम सिटिंग विद सम जिंदा पीपल. Okay, done. Noted, everyone?
Yes, sir.
Okay. And now I'm giving you two home assignment that you have to try and we'll discuss in next class.
So are there the questions on the group?
Sorry?
Are there the two questions on the group, sir?
Yes. Here also in here also I put this question. These are the two assignments that you have to try and we'll discuss in next class. Right. I just copy pasted now. So ignore these are the extra terms that came because of the alignment of the book.